Welcome to lecture 4 of basic electrical engineering. Today we will study resistors in series, resistors in parallel, and combination of series parallel connected resistors. So resistors in series, if we have two resistors in series R1 and R2, their equivalent is written as R1 plus R2, their linear sum, the unweighted linear sum. R equivalent is R1 plus R2. If we have more than two resistors, for example n resistors, the equivalent resistance is R1 plus R2 plus R3 plus R2 Rn. It can also be written in a short form like summation Ri. If we have resistors in parallel, the two resistors in parallel R1 and R2, their equivalent can be written as R equivalent is, in fact, 1 over R equivalent. You have studied it in elementary classes. 1 over R equivalent is 1 over R1 plus 1 over R2. It can further be simplified. It can further be written as taking R1 and R2 as LCM, R1 times R2, we will write R2 plus R1. So inverting the ratios on both sides gives us R equivalent is R1 R2 over R1 plus R2. So this is how we can write equations, an expression for equivalent resistance given the two resistors in parallel. Extending it to the case where we have n resistors in parallel, the expression can be rewritten as 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. The general case for n resistors. Now we'll solve two examples where we have resistors connected in series and parallel. Example 1 is a circuit having two resistors R1 and R2 connected in parallel and R3 in series. So R equivalent, if you want to calculate R equivalent between these 2 points, let's call them A and B. Between A and B, we'll start from the opposite side. We'll start from R2. R2 is in parallel with R1, and then this can be replaced with a single resistor. We call this as R1. In these two pipes, this pipe containing these two vertical lines is a symbol used for parallel connected resistors. R3. So R1 pipe R2 means R1 in parallel with R2, then it is in series with R3. So R equivalent is now R3 plus the parallel combination of R1 and R2. The parallel combination can also be written as R1 R2 over R1 plus R2. So this whole plus R3 is R equivalent for this circuit. We have another example. Example 2. We have a bit complex circuit. given this circuit, this is 18 kilo ohms, 12 kilo ohms, 6 kilo, 4 kilo. Right. So we are supposed to find R equivalent between these 2 points, A and B. So we'll start from the opposite side. It's 4K. 4K can be seen that the same node, this, and this are the same node. So we can see that the top ends of 4K and 6K resistors are connected together. The bottom ends of the same 2 resistors are connected together. This means 4K and 6K are in parallel. So solving 4K and 6K in parallel gives us R1, R2 over R1 plus R2, 6 4s are 24 over 10. So this gives us 12 over 5. So this whole can be replaced with 12 over 5. It can be replaced with a single resistor having magnitude 12 over 5. Now we have this 12 over 5K resistor in series with 12K resistor. So 12 over 5K plus 12K. 12 over 5 plus 12 gives us 72 over 5. So these 2 resistors can be replaced with one resistor having value 72 over 5K. Right. So now we have only 2 resistors, 72 over 5K in parallel with 18K, which can be solved. 72 over 5 is R1. In parallel with 18K means 18 over 72 over 5 plus, so R1, R2 over R1 plus R2. Solving this gives us an answer equal to 8K. So R equivalent is 8K in this case. Now the student is supposed to solve further examples from the textbook regarding series and parallel combinations of resistors. Thank you.